Chia-Chi Chang is going to talk about hacking models with Python. So let's give him a big hand.
Hello, everyone. Well, it's a lot of people. Today, I will share the topic about the hacking models with Python. And I love to talk this series of hacking model. But today, my slide has some trouble like this. So when I build a slide from the IPython, and I don't know whether the slide it doesn't work and has some trouble. So in that part of my talk, I will accompany with my original IPython notebook to explain the text mining part. And okay, let's start. I try to start my talk. Today I will introduce you the hacking model with Python, and my work is at the data analysis area, and I try to build a lot of mathematical model every day. So when I'm building mathematical model, I find there are several limitations of mathematical modeling, and I find the limitation and the blind spots, and I try to break through them, and I will share some of my experience today. And back to the original question, what is the mathematical modeling? In my experience, I think mathematical modeling is just like sketching. It's very similar. And when you are sketching something, the first of things is not take the pen. The first of thing is the first step, you need to choose an angle. And after you choose an angle, you will choose a view of point, and then you need to do some observation. The observation is most important thing, then take the pen. And it's the first step. So after you observe your object, and you need to observe a lot of details, something like shape or luminance or shadows, and after that, you will try to draw some draft, and then remember that whatever you observe, whatever you draw. So observation is most important, and it is more important than take the pen. When you start to take a pen to drawing something, you must follow this path from the macroscopy to the microscopy. You can see you first sketch the large scale structure and go to the detailed structure. Both the shape, the shadow are the same from the macroscopy to the microscopy. Okay, here comes the problem. I say that data analysis or mathematical modeling is very similar to the sketching, and how they are similar. Here comes a problem. Here is the two-dimensional data, and how to draw the picture, and how to draw the picture to sketch the data. I know here has a lot of hackers. For hackers, we will say that just do it. You just draw it, and draw and find what is the best picture. And this is the spirit of hacker. So I try to draw a lot of lines. It's just like the picture, and because the two-dimensional data is very easy, so you can use the line to represent the picture, the structure of the data. And when you are drawing the lines and the same, you can use another plane, two-dimensional plane, to represent your models. And each line can represented as a point on the right-hand side plane. And you can use the slope and the intercept to represent a line on the left-hand side. So each left-hand side a straight line is just a point on right-hand side plane. So after you draw a lot of lines, just as a lot of picture or sketching for this data set, and we will ask which line is much similar to the data. It is which model has more accuracy. So similar and dissimilar is very subjective. It depends on your view or point. Remember that I say that when you are sketching something, the first step is choose an angle and stay in a view or point. And when you are stay in different angles and you stay in different view or point, you will have a very different evaluator to say what is the similar things. So she cannot say that your picture is not similar to the tree, because she always view the point from his side, not from from her side, not his side. So how can she evaluate others picture from his side? But attention, your viewpoint is also an evaluator, and we always use our evaluator to evaluate other. So this is the key point, and it's also the hacking models, the key of hacking models. So in linear regression, the standard evaluator, or we can say it is a standard viewer point, is this square arrow. And after you write this square arrow, you can see it's also a two-dimensional function, and you can draw the level curve on the plane, and draw those things together. You will see what is similar or dissimilar from the square arrow viewpoint, and we draw the square arrow level say on the left-hand side plane, and we can see the small distance the point has, and the similar the point is, the model is. So this is this square evaluator. So how to solve the best model from one line? Python is a very powerful language. So you can use a SciPy package, and the SciPy has the optimal and the optimal package. It has a minimum function, and you can call this function by setting up your objective function, just like a define sum function or lambda sum function, and call into this function, and they will give you the solution. What is the minimum of the function? So you can find the best solution, and it's correspondent to the best line on the right hand side. So as a model hacker, we always try to build a solver by ourselves. Well, it's a lot of people, so we always try to build the solver, and it's a smooth problem, so we can use it's a complex problem, so we can use the gradient descent method to build to find the best model. Also, as a model hacker, we will ask as a hacker, we also want to change a lot of things, and change anything you can change, no matter what others say it is not unchangeable or it cannot change. So you always try to change anything. In this setting, you always try to change the viewpoint, and we will want to ask ourselves or ask others, how come when you change the viewpoint, or how come when you change the evaluator? change a different viewpoint to see the same thing, we'll get the different result or the same result. Okay, the simplest change process is adding the weights. In the original standard form, there is no weight for the arrow, and you can simply adding the weights in front of the arrow. So you can compute that the arrow didn't compute equally, and you may say at this point this data point is more important, so I need it more accurate. So I compute the error of this data point more larger, even it's just a small error can be amplitude very large. So you just add the weight to the error. So I adding to point 100 times to other point, and we can see that the evaluation function will change, and also your best model is also changed. So try to change the evaluator, and you will get a different solution. And if you change with 10 times, 100 times, and 1,000 times, then the level curve will animation from this process. You can see it's just like the metaphor. The data point is just like the tree, and we use the different evaluator as a different viewpoint to draw the different pictures like this. So to the different viewpoint to draw the different pictures. Why it is important? Because the directly problem, we always use data and the evaluator, and we can get a model. But for social network analysis, or for some recommendation system, or we always try to modeling users' evaluator, and every user has different evaluator. So you need to try to solve what is the user's evaluator. You need to guess, and it is a very, very hard problem. So we can from the simply problem to try to approach it this way. So it's a directly problem, and model hacker always want to solve the inverse problem. That is, you have the data, and you have a model in the data. If you can construct the user's evaluator, so it's an inverse problem, just like this. If you saw a picture, and you know what is the object in the picture, and the picture is just a model, and you saw a picture, it's just like data, and how can you find the evaluator? How can you find where the painter draw the picture? So it's an inverse problem. So inverse problem is just like this. And if you find some shooting, and you want to find the trajectory of the shoot and the position of the shooter, so it's an inverse problem. Sorry. So what is so how to find? The only weapon we have is data. So you need to listen to the data and the observation. So be careful to listen to the data. You can get a lot of things and a lot of informations. And back to the inverse problem of regression. We will. Oh, it's a lot of notation. Let's skip. And this is a weighted evaluator, and we can derivative and we all know the optimal condition is the derivative the objective function and equal to 0. Then you can drive this formula, and after you drive this formula, this is the optimal solution. So the right problem is we know the W's, and we try to figure out the A0 and A1. And the inverse problem is now we know A0 and A1, and we try to solve the W's. So inverse problem, you can try to solve this. Set the two equations equal to E0 and Z1, and we want to E0 and E1 to be zeros, and achieve an optimal solution, and try to solve the W's. Okay. Okay, this is the original problem that is 100 times to other point. And this is the inverse problem, the weight of the inverse problem. You can see these points are a little bigger than the original one. So it is not solved to the same iterator, but they have the same picture, but a different iterator. So this says that this equation has the infinite solution. So which one would you want to choose? Yeah, it's just like this. This equation has this infinite a and b greater than, they are infinite a and b greater than 0, and this problem has a optimal solution at 0 point. So a short summary is accurate. Hacking model is not hack the models, actually hack your viewpoint and hack our iterator. Because whatever we observe, whatever we draw. So next we will discuss about the limitation of modeling. That's the first part of this talk, and this is the second part. And the limitation, I will discuss two things. First thing is the limitation of frameworks, and the second thing is the disappearance of unit of measurement. So let's start. There are two primary frameworks in machine learning frameworks. The first kind is supervised learning. It has classification methods and regression methods. And the second kind is unsupervised learning. It has clustering methods and dimension reduction measure. And I will give you some example in classification method and the clustering methods. First, the example of classification method, I will give you to classify the apples and the origin. So try to build an apple and the origin classifier. You may use a very complicated features to distinguish them. And finally, you will get some models like this. Maybe the green is the apple, the red is the origin, and you will give a boundary to classify them. And every classification method has the coverage accuracy trade-off. Just like when you are trading in a smart market, then you will have the winning probability is important, and the WL ratio is also important. And the expectation is greater than 0 must ensure by this inequality. And it's just an example. I want to say is the how to make the winning profit grow. It has two strategies, and it's very different to our intuition. How the first strategy is adding the weights to the winning event, and the second is adding to the loss event. But accuracy, suppose the green point is the winning event, the original winning probability probability is 80%. And when you adding the weights to the winning event, then it goes down. It's not goes up. So you need to adding the weights to the losing event, then the winning probability will goes up. But after the winning probability goes up, then the coverage goes down. It's just cover 3 winning events. So that is classification method. So the limitation of classification method is just that you build a origin and apple classifier, and you get a banana picture, and then your classifier will send the banana into maybe apple or origin. So that is the limitation, and it's a very big problem when you are using classification method. And another method is clustering methods. Okay. When you are using like this, so my side has some troubles in this, so I will use the iPad notebook to still. In scikit-learn, there are several benchmark testing in clustering method, and I like to use spectrum clustering and deep scan. And here are some example when we are trying to use the clustering method in the handwriting digital data set, and you can see the k-means will very very terrible, and the clustering spectrum clustering is awesome, and deep scan is also. So what is the limitation of clustering? The limitation of clustering is you cannot put two data together. You cannot just let data to put they are aggregated together by their distance. So how to hack the clustering method? The key point is the distance. If you control the distance, then you can control the clustering method, also the classification method. Actually, everywhere has decent structure. Something like this. We all learn the equation in the elementary school. We know that 103 minus 100 equals to 3, and the 6 minus 3 equals to 3 also. So let me try to adding back the units of measurement. Let us adding the dollars, and we will see, that's fine. $103 minus $100 equals to $6 minus $3. And another, we adding back to the dollars of stock, and you will feel it is not right. Maybe I think the left hand side is more small. It's smaller than right hand side, because in my opinion, I think $103 stock minus $100 stock is smaller than $6 stock minus $3 stock. It's actually it's a different distance definition. So we can see our intuition of is hide in the distance. So for data mining, how to learn the distance is very important things. It's also in the text mining example that there are several examples that the weather today is good, the weather today is bad, the weather today is great. Also, I hate him and he hate me, something like this. And in Chinese, I hate him and he hate me has the same 3 words. So if you use the unigram to model this sentence, then they have no this difference. So the model will say that they are the same. So you can choose another features like background, then they will separate. And this is not talk about the distance. And the most important thing I want to say today is the distance learning, and how to build a distance learning. The weather is good, bad, and great. We will see that the difference between the sentence 1 and sentence 2 is this, and the sentence 1 and sentence third sentence is this. So use the original Euclidean distance. We will compute that the distance of 1 and 2 are this. And if we use the different metric, then we can compute different distance like this. We can set let the distance down to the 0 or more larger. Just like this, you pull together and push different labels. So okay, so that's the machine learning, and I think it is a future of the data mining, because you can see that this is a sandwich data set, and if you use the original distance, you will compute the layout together. But if you use machine learning, you can separate very perfectly, and you need not to label every data, and you just need label some of data and use the semi-supervised learning to do the label propagation. And you can if you learn the right metric, then your clustering method has the same power to the classification method. Finally, you can use the convex optimization package to solve this, and use the Sogang. There is an LMM solver to solve the machine learning problem. And finally, I want to say that hacking model is not hacking the model. It is hacking the view of point and the evaluator in our mind. It's very important, and I hope everyone can break through the limitation and the blind spot of the model. Thanks, everyone. Sorry, I have some troubles in my slide, so I need to use the iPad notebook to finish the talk.
Okay, first, thanks Chia-Chi for his great talk, and I think we have 2 or 3 questions. So, is there any questions? Okay, please.
No, as a hacker, we hack everything, and I mean, do you have hack your data?
Data?
Yeah, because
how do you mean hacking data?
Because if you collect data, but the data is not 100% trustable.
Yeah.
Yeah. What will you do?
Yeah, but actually we seldom hacking the data, because if data has some noisy part in the data, you can do some projection and you get the new data.
Oh,
but
I
don't
mean the noisy, because you take the gunshot
你可以说中文。
因为你刚用了枪击案当例子。
Yeah.
And if the data is somehow 人为的。
Yeah.
Yeah. So can you hack the 那个
？Yeah, we are also trying to build the user behavior models when we are monitor the users, and you can also collect a lot of information from the shooter. Will maybe have some hairs on the or so you can use a lot of additional information. Hacking data in real world, you have a lot of information, additional information. But hacking data in paper, you need to remove some data. You cannot use the additional information. So that's the difference. Okay, it's a very good question, because traditionally we say it's a good model or bad model. We use the absolute evaluator, But if you use the machine learning or something like a user behavior model, so you use the relative model. So you relative evaluator to choose the relative model. So how to say the model is good or bad? It depends on the viewpoint and the evaluator you use. And you can also bind two evaluator together, form a new evaluator. And you can also compute two evaluators distance and try to modeling. Some of people may like the same thing, and other people may like other things, and this the evaluator. So you can also classify the evaluators, and if you want to say the accuracy, you need to check out what is the evaluator you use now. Yeah, it is relative. It's not absolute. It's very different to the traditional way.
Okay, I guess that will be the end of this talk, and let's give him a big hand. So thanks, Chia-Chi, for his great talk.